Good morning, class. So for today, we'll continue with our the next topic for environmental chemistry. Now, this time we'll be talking about acids, bases, and neutral substances. Um, yeah. So when we talk about acids, usually we refer to the common thing that goes with it would be the term pH. Okay. So pH, we can think of pH as a range. So it ranges from 0 to 14. But what makes pH special, as you can see here, you work from the middle towards the end. So um, let's say, for example, you have this. You see here 7 and above will be different. 7 and below will be different. So like 7 will be in the middle of that scale. So in a way, like if you will look here, 7 will be classified as salt solution or neutral solution. Okay, so like in this case, water is pretty neutral. It's not acidic, it's not basic. Okay, um, and that's why it is placed right smack in the middle. Now you will see here, blood is slightly basic, and then your milk is slightly acidic. So from 7, so above 7, it will be a basic substance, and we'll be discussing that more. What is a basic substance? Um, and then below 7 will be acidic substances. So you will see here, you have, I think this is hydrochloric, so that's hydrochloric acid. You have lemon, you have apple, you have bananas, you have vinegar, tomatoes, and those things are considered um, acidic substances. Now, baking soda, soap, ammonia, drain cleaner. Now, if you have heartburn, you will take in Tums. Those are considered basic substances. Okay, measure the percent of hydrogen ions in a solution. So in this case, the more hydrogen ion, the more hydrogen ion present, the lower the pH. So again, remember that the more hydrogen ion present, the more acidic the solution, the more lower the number. So it's bidirectional scale. 7 will be um, so 7 left, 7 right. The difference between one number and the next on the scale represents a tenfold difference. So let's say, for example, 0 is 10 times more acidic than 1. Okay, so every number that you increase, um, it will be multiplied by 10. So in this case, let's say for example, so always remember, the lower the number for acids, the more acidic it will be. Again, the lower the number for acids, the more acidic it will be. So again, let's go back to the scale. Any number lower than 7 will be considered an acid. Any number greater than 7 will be considered a basic substance. Now, um, so as you go to the extreme, as you move further away from 7, let's say if you're going to the left, as you move farther away from 7, it will become more acidic. Uh, from the right, if you're moving to the right, as you move further away from 7, you become more basic. Now, so let's say, so just to give you an example, um, pH of 3, okay, will be 10 times stronger than 4. So for some of you, you might find this a little confusing, but the thing is, again, if you go um, from right going to the left, okay, starting from 7, from right going to the left, it becomes more and more acidic. So in this case, 3 is more acidic than 4. To be specific, 3 is 10 times more stronger, more acidic than 4. Or in this case, 2. So let's say, what if the difference is 2, right? So it's gonna be 10 times 10, right? So if it's a pH of 2, for the pH of 2, so this is 10 times stronger than 3. And then I told you a while ago that 3 is 10 times stronger than 4. So 10 times 10 is 100. So therefore, a pH of 2 is 100 times stronger than 4. Make sense? Again, since 2 is 10 times more acidic than 3, and 3 is 10 times more acidic than 4, so basically you just multiply 10 times 10. Now, um, Say for example, and then in this case, 10 and 9. Okay, so 10 and 9. Um, so a pH of 10 is 10 times stronger than the solution of a solution of 9 if we will be looking at how basic the substance is, right? The more basic it is, the more you move to the right. Now think about this. Oh, let's see. Let's look at another one. Now 11 is 100 times more basic than 9. Because if you will think about it, 11 and 10, 11 is 10 times more basic than 10, and then 10 is 10 times more basic than 9, so it's 10 times 10, you will have 100. Now, so just a question for you guys. How will you compare the pH of 1? How much stronger is 1 compared to 5? Pause the video. Okay, so let's think about it. So 1 is 10 times greater than 2, and then 2 is 10 times greater than 3. 3 is 10 times greater than 4. 4 is 10 times greater than 5. So it's 10 times 10 times 10. Sorry, it's 10 times 10 times 10 times 10. Then your answer will be what? 10,000. So 1 is 10,000 times more stronger than a pH of 5. Okay? So don't say that, oh, you know what? The pH of my stomach, the pH of the acid inside my stomach has a difference of, just one pH. No, like if you will think about it, it's 10 times, right? So let's say, for example, oh, the pH in my stomach, the pH of the acid in my stomach is now 5. Well, if you will think about it, that's 10 times stronger than 6. And if our goal for the pH is 7, then that's 100 times more acidic than a pH of 7. Okay, next. Okay, so acids. So the common characteristics of acid would be sour in taste, and that's why. So acidic substances would be vinegar, lemon, orange, those things. Okay, sour and taste. Um, the stronger acids can actually burn your skin. Okay, which is actually uh, dangerous. I will be showing you some pictures maybe next time. And then for a solution will be lower than 7. So remember, acids will have a solution lower than 7. Now base will be slippery and bitter. Solution that is higher than 7. So those will be calcium carbonate. So anything like better taste materials will have most likely will have a pH higher than 7. Now, a neutral substance, neither an acid nor a base, will have a pH of 7. Okay, so how do we measure the pH? So we have a pH meter, digital probe. So we have that. So basically, you will get a substance, put the probe there, and then you will see the pH reading there. There are some like compact materials that you can actually just, like for example, for my tanks, I can just use those like portable pH meters. You will just dip it in the tank, press the button, you'll get the pH. What I would use, okay, well, I don't have it here, but I have this. Okay, so for this one, since I have fish tanks, I would use this for measuring the pH. It's actually is very important because the lower the pH, the less likely the fish will survive. So because they don't like acidic, well, except for some fish that can actually thrive in lower pH or more acidic environments. So in this case, this is what I will use. Okay, so this is a freshwater master test kit. So basically, what I will do is just collect some water samples from my aquarium, and then mix them with a certain chemical. Like in this case, okay, this one is the pH test solution. So what I will do is put 3 drops of this, and and then the solution will turn into a certain color. And now you will just compare the color of the solution to the scale here, and then you will see the pH. So you'll see it there. Okay, perfect. Now, so that's another way. So I'm using this one. So the so like the solutions here is what we call indicators. So basically, they change color, and as they change the color, they tell you what the pH is. We have a lot of these in school. Unfortunately, we can't do that experiment, but I'll be showing you. I mean, I'll be doing a virtual experiment with you guys. So ayan, hopefully, you will still learn something from that. Okay, so this one piece of like small piece of paper that will tell you if it's an acid or a base or what the pH is. Okay, so question for you: if the pH is 6.9, what is it, an acid or a base? If your answer is acid, then you're right. If the pH is 13, it is a base. Okay, if the pH is 7, it's a neutral solution. Okay, let's go on to the next one. Another indicator or another way to tell whether it's an acid or a base is the litmus paper. So what will happen? What happens is that if the solution is an acid, the red litmus paper will remain red. Again, if the solution is an acid, the red litmus paper will remain red, and then the blue litmus paper will turn to blue. Okay, if the solution is basic, then the red litmus paper will turn to blue, and then the blue litmus paper will stay the same. Now, if it's neutral, both of those two litmus papers will remain the same. Okay. Okay. So red will still be red, and then blue will still be blue if you have a neutral solution. Okay. Um, which of the above liquids are acidic, basic, or neutral? So you have here test results showing effects of 7 different liquids on red and blue litmus paper. Okay, so you have red here, you have blue here. Which of the above liquids are acidic? Okay, so if it's acidic, we'll just look for the liquid that turns blue litmus paper. Okay, so this one turns red, this one turns red, and this one turns red. Okay, then therefore that is the acidic um, solution. Now, which one is basic? So basic, we know that a red litmus paper will turn blue if it's a basic solution. So this one turns blue, this one turns blue. So yeah, ammonia and liquid X um, will be the basic solutions. Now, obviously for neutral substances, no change for both the red and blue. So no change here, no change. So water is neutral. No change, no change. Liquid Z would be neutral. Neutralization. Okay, and you would usually do this right when you feel like your stomach is a little acidic. You're like you're experiencing heartburn and those things. You will take in Tums. That's a process of neutralization. So basically, if you have way too much acid, you want to add a base in order to make it neutral. Or if you have too much base, you will add acid to make it neutral. So in this case, neutralization is basically a reaction between an acid and a base to produce a neutral solution. Okay? So like in this case, you have hydrochloric acid, you have sodium hydroxide, and notice here when sodium combined with chlorine, you have NaCl, and hydrogen from acid plus OH from the base, you have H2O. So therefore, you have a neutral solution. You just have water and salt. That's it. So it's not as damaging. It's actually not damaging to your system because you don't have excess acid or excess base. Okay, taking an antacid for upset stomach. So basically, antacid is a mild base that will lower the acidity, that will somehow try to try to increase the pH of your stomach acid. Okay, to make it more neutral. Acid rain. So normal rainwater is naturally slightly acidic. Um, Raindrops dissolve carbon dioxide from air from form a very weak acid called carbonic acid. So basically CO2, and then if you combine that with H2O, somehow the hydrogen from water will react to form carbonic acid. Okay, which will lower the pH of water. Now you have acid rain. Um, and that's what usually occurs, especially here in Canada. Long winter, long winter, and then people are driving. There's no rain, no nothing, and then during spring. with the amount of nitrates, sulfates, carbon dioxide in the atmosphere, because we did burn a lot of natural gas during those times, because we need to supply our bodies with heat, and our houses, we need to burn fossil fuels or natural gas in order to keep our house warm. Then you're producing a lot of nitrates and those things. Okay, when they combine with water, the hydrogen from water will combine with them, then you have a lot of acidic materials. Now you have acid rain. Now pH will be less than 5.6. So these chemicals dissolve water to form acid. So carbonic acid, sulfuric acids, and nitric acid. Okay, like those things. Sources will be industry, transport, domestic electricity generation, and a lot of those things. Now, when they go to our atmosphere and then combine with water, when it starts to rain during spring, now we have a problem. Now, there's just one time a huge lake, or a huge lake in Canada experienced this. The pH actually went down to 3, which almost killed all the living organisms in that area. So what the Canadian government did is they did put a lot of calcium carbonate, in order to neutralize, again, the term is to neutralize the acid, in order to increase the pH, okay, to its optimum number, so that it will not kill the fish present there. So concerns: acid rain can cause bodies of water to become acidic, and they can actually kill fish. Okay, acid rain kills river. This river is dying. Okay, most organisms can only survive in a narrow pH range, and that's the reason why, for my fish tanks, I'm checking the pH, just to double check. And what would graphical representation of this look like? So like this one, so this is the original statue. Acid rain can react with calcium carbonate and dissolve it. So this is over time, and this can actually cause a lot of damage. If you will go to Rome and visit the Vatican, um, I think they did spend like millions and millions and millions of dollars just to restore the statues around the Vatican City. Okay, during the World Youth Day. So just try to take a look at this question and then analyze it. Okay, so now just try to take a look. So which of the four species here, A, B, C, D, is the most sensitive? So in this case, the species D will have, it's very stable, and then all of a sudden, when it's so now, so meaning they are sensitive if they can only survive in a very, very, very narrow range. So in this case, species D, since this range is very narrow, between 6.5 and 7, then species D will be the most sensitive. So acidic flakes can be treated with lime, calcium hydroxide. Calcium hydroxide is a base. So the OH here will take the H from the acid to form a salt, to form salt and water. So always remember, an acid reacting with a base will produce salt and water. So results in neutralization. So in this case, you have a salt, calcium sulfate, and water. Okay. Um, yeah. So I will be posting these online labs, and I'll create an activity for you guys. Have a good day. God bless you all.